Uh, Hi. The topic today we're gonna discuss is Hadoop DB, an architectural hybrid of MapReduce and DBMS technologies for analytical workloads. The paper by Azab Zodi and Kamil Bajda, and presented by Nikita, Ritvik, Deepthi, and Himavamshi. Uh, we go to the as we move on. This is the outline of our paper. These are the things we're gonna discuss in the coming slides. And the first slide would be about analytical DBMS systems. So, what are analytical DBMS? This is a kind of database management system which specializes in big data management that is useful for business applications and services. This is designed in such a way that the main benefits of this analytical DBMS is to provide quick query response times and advanced analyticals. And the main features include the column-based storage, in-memory loading of compressed data, and the ability to search data through multiple attributes. This analytical database has been become popular due to the limitations of current OLTP relation and multidimensional databases. And this has become a foundation technology for implementing a data warehouse. The uses and examples of analytical database is it is used to quickly analyze large amounts of data, and the performance of these database are 1,000 times faster than the operational DB. It also used to help to determine the best process for transactions and other business or research decisions. And some of the examples include market data, transactional data, sensor data, natural language data and process data, and machine data. So what the key properties for very large scale data analytics are: first one is performance. Mainly the performance is used to compute the results of a query faster. As we know, the performance is the primary characteristics that commercial database systems use to distinguish themselves from solutions. And the next is fault tolerance. Uh, in the context of analytical data workloads is measured differently than fault tolerance in the context of transactional workloads. So rescheduling paths of query execution in the case of node failures is where fault tolerant is used. And the next property is ability to run in a heterogeneous environment. As described, there's a strong trend towards increasing the number of nodes that participate in query execution. So attaining same performance from all the machines is difficult. And the next is flexible query interface. This should support ODBC and JDBC and user-defined functions. There are a variety of customer-facing business intelligence tools that work with database software and aid in the visualization, query generation, result dashboarding, and advanced data analysis. These are the important part of analytical database management systems. And the next would be continued by Ritvik.
Hello everyone. So now we are going to see the architecture of Hadoop database system. So in the very bottom figure, we can see that there are basically three major components of the Hadoop ecosystem. The first one is HDFS, the second is Yarn, and the third is MapReduce. In the very first figure, we can see that there is on the very right side we got the data loader, which is responsible to initially load the data, and this data will be stored in the raw files. Then we have a catalog which is connected with the SMS planner. So both these are responsible for the processing the SQL query. So now let's see the each component of the ecosystem in very detail. So the first one is the HDFS, which stands for the Hadoop Distributed File System. So basically is used for the store the massive amount of data, and all this data will be distributed into the, instead of storing into the one system, all the data gets divided into the smaller blocks. So the by default limit is 3. However, we can also update this block limit manually too. So here we can see in example, we go HDFS got the data of the 400 MB. So it further allocates into the 4 different. So the 3 of each block gets 128 MB data, and all the remaining data will go in the remaining block, which is D. So which contains the 16 MB of data. So there are two main components of HDMS. First one is a name node and the second is data node. So name node is often referred as master and the data nodes are referred as the slave nodes. So the master node is responsible for keeping all the information about the slave node. So it contains all the metadata info. So it tracks all the data information about the slave node. So it contains information like what is the log, the files, what is the schema, and what is the driver class information, IP addresses, usernames, and all. Whereas on the other hand, data node contains all the information about the actual data which is requested to retrieve, which is requested for the retrieval. So the next one is the map reduce. So map reduces basically works in two independent methods. The first method is map and the second one is the reduce. So map is responsible for fetching all the information from the different slave nodes, and what reduce method basically does, it combines all the data of the map method, different map methods, and then after combining it, pushes it to the forward for the outputting. So the third component is the yarn. So it stands for the yet another request negotiator. So it works behind the map reduce method. So it basically responsible for the two tasks. The first one is the job scheduling and the second one is the resource management. So in the job scheduling, it basically it does the thing all the related, which is timing of the job timing and scheduling. It gives the more priority, which are the more important process or query, and the resource manager of the resource management manage all the resources, so that it just take care of all the things which is responsible for running a Hadoop cluster in a more efficient way. So basically there are four main components of the yarn. The first one, as we can see in the figure very right side, the first resource manager, then we got node manager, application manager, and container. So what basically happens is once the task of the map reduce is done, the application master sends the request for the accessing the resources to the node manager. Then node manager tries to get all the requested resources from the container, and once node manager gets all the resources, then it pushes forward to the resource manager, and then resource manager forward it for the outputting. So there is a other program, other scripting language too on the top of the three major components, that is Hive and Pig. So these both are used for someone who doesn't want to code in Java, since the whole Hadoop system is written in Java. So these two languages provides the more flexibility. So in the example, we can see that we got the demo.txt in which we got the two data. So ID, roll number, and then name. So Hive has the HQL, which is almost similar to SQL, in which we have to, so if we want to retrieve the data based upon the any condition, so we just provide, it's almost similar to the SQL. So we just have to write, select from the demo.txt, which is just a file name, and then condition based upon which we have to retrieve the data. And there is a pig, which has its own language, which is known as pig script. And in pig script, we have to write load keyword, then the name of the file, and then using keyword, and then pig script, and all the column names which are on which we try to retrieve the data. Okay, so the next topic will be explained by my friend. Please continue.
Hi everyone. Now the problem is data exploding. Database system is moving to cheap, lower than commodity hardware. The cause for the data explosion is, the basic reason is that more people have more tools nowadays to create and share information than even before. As the market is huge need to find a solution to the problem. And now the next slide. Now the available approaches are parallel. DBMS and MapReduce. The next slide, please. Yeah, parallel DBMS. These systems all supported standard relational tables and SQL and implement many of the performance enhancing techniques developed by the research community over the past few decades, including indexing, compression, and most tables are partitioned over multiple nodes in a shared nothing cluster. However, the mechanism by which data is partitioned is transparent to the end user. Parallel database uses an optimizer tailored for distributed workloads that turn SQL commands into a query plan whose execution is divided equally among the multiple nodes, and it's also a pricey one. In the next slide, please. Yeah, the second approach is the MapReduce. MapReduce best meets the fault tolerance and ability to operate in heterogeneous environment properties. It achieves fault tolerance by detecting and reassigning map tasks, failed nodes to other nodes in the cluster. It achieves the ability to operate in a heterogeneous environment via redundant task execution. Tasks that are taking a long time to complete on slow nodes get redundantly executed on the other nodes that have completed their assigned task. Therefore, it is possible for each task to do anything on its input just as long as its output follows the conventions defined by the model. Thank you. On the next is continued by my friend.
Hi everyone. Now I'm going to SQL to MapReduce to SQL Planner. Hadoop DB provides a parallel database front-end to data analytics, enabling them to process SQL queries. The SMS Planner extends Hive. Hive transfers HiveQL, a variant of SQL, into MapReduce jobs that connect to tables stored in files in HDFS. The MapReduce job consists of DAGs of relational operators that operates as irritators. Each operator forwards a data tuple to the next operator after processing it. To understand how we extended Hive for SMS, as well as the difference between the Hive and SMS, we first describe how Hive creates an executable MapReduce job for simple group by aggregation query. Then we describe how we modify the execution plan for Hadoop DB by pushing most of the query processing logic into the database layer. Next. Now we're taking an example query, like select your scale date, some review from a scale group by data scale date. So now, next. Hive processes the above SQL query in a series of phases. The phaser transforms the query into an abstract syntax tree. The semantic analyzer connects to Hive internal catalog, the meta store, to retrieve the schema of the scale table. The logical plan generator that creates a DAG of relational operators, the query plan. The optimizer restructures the query plan to create a more optimized plan. Finally, the physical plan generator converts the logical query plan into a physical plan executable by one or more MapReduce jobs. The above SQL query results in a single MapReduce job with the physical query plan illustrated. Next. So now the conclusion, Hadoop DB is therefore a hybrid of parallel DBMS and Hadoop approaches to data analysis, achieving the performance and efficiency of parallel databases. It's still yielding the scalability, fault tolerance, and flexibility of MapReduce-based systems. The ability to Hadoop DB to directly incorporate Hadoop and open source DBMS software makes Hadoop DB particularly flexible and extensible for performing data analysis at the large scales expected of future workloads. Next. So here are the few questions that we have prepared for the students. Thank you.